Good morning, ladies and gentlemen, on this wonderful Friday. It is a Friday, I believe, April the 3rd, 2020. Now, what we're going to be talking about today is that we're going to continue from exponential functions. Remember that an exponential function is y is equal to a times b to the x power. Remember, your x is in your exponent, that's the variable. And yeah, let's say you can see that. But what we're going to be moving on now is what we call a change of formula, because we are going to be trying to find the inverses of our exponential functions in order to figure out what this x is. Often we use an exponential function to figure out what y is, but when we need to do the opposite, well, we have to, if we want to find the opposite variable, we have to find an opposite, well, we have to use the opposite operation. So the opposite of an exponential function is what we call a logarithmic function. It should be written like this: log base b of y divided by a is equal to x. Now, some mathematicians might say, oh, you're going to switch your x and y. But I like to write it this way to really see, to let my students know that it is the inverse operation. It's the inverse process. Where this had y by itself because we were trying to find y, this says x by itself because we're trying to find the x, we're trying to find the opposite one. So, what I wrote up on the board is written down here as well. If I have y is equal to a times b to the x, with a being your first term and b being your base, your rate, do remember that base and rate are the same thing. Writing with a pen on this using a mouse, not easy. Not easy for me, maybe it's easy for you. But we're simply just moving these terms around. So, if I have this, change y is equal to 5 times 2 to the x into a logarithmic function, I notice that 5 is my initial term because it's the one without the exponent. 2 is the base because it has the exponent. So this is going to be log base 2 of y over 5 is equal to x. Now, I included this as well because not everyone has a calculator that will allow you just to be able to write a log and put in a base at the same time. A lot of older TI models and a lot of older graphing calculators make you figure out, hey, if I want to figure out what x is, I have to write log of y over a divided by log of b, because this makes it back into the original log base 10 system. But that's a different lesson for a different time. That's just saying if I want to figure out, if I had a value for y, I could actually figure out what x is by doing log of y divided by 5. Now, one thing you might want to remember to do is put parentheses on. Definitely put parentheses around your things. Log of 2. And that will give you the value of x. And this is a logarithmic function. It is the inverse of the exponential function. A little fun fact about exponential functions and logarithmic functions: logarithms were created specifically just so we could do exponential function calculations super quick. But now that we have calculators, we use logarithms to really figure out things like interest and stuff like that, along with exponentials. So for this check for understanding, take 10 seconds, pause the video, and see if you can change this exponential statement, 100 is equal to 25 times 1.5 to the x, into an actual logarithmic function. Once again, take that time, figure out that right now. And so, if I know this is my y. That's log of 100 divided by something, your first term, divided by 25. Now, Mr. K, where does this 1.5 go? Well, admittedly, let me change my pen color. I just clicked pen. Let me change my ink color. Your 1.5 is going to go right. You can ask my students, I love changing the color of my writing utensil in the middle of the lesson. Log base 1.5. Log of, how would you say that correctly? Log base 1.5 of 100 over 25 is equal to x. Now, Mr. K, surely that's the final answer. We placed everything down and that's entirely what we did on the previous problem. Well, yes, but what's 100 divided by 25? This is the same thing as log base of 1.5. So log base 1.54 is equal to x. Now once again, that's the same thing as log of 4 divided, that's a horrible division there, log of 1.5 is equal to x. Now, you can actually calculate that, but I'm going to save that for the next part of the lesson. Because I want us to actually take information, take models of information, and be able to figure out, hey, I either need to solve for an x, or I need to solve for a y. Because not everything is going to be, oh, just rearrange the stuff and crank out an answer. But instead, let's take these two equations, find us the value of some variables. So, a radioactive substance is decaying such that 2% of its mass is lost every year. Originally, there were 50 kilograms of the substance present. We want to first write an equation for this amount, and then find the time it takes for only half the initial amount to remain. So, let's just start on this first one. Write an equation for the amount. Well, a radioactive substance is decaying as such that 2% of its mass is lost every year. Taken from our lesson yesterday, we're going to probably be looking about for how much is going to be left. So I don't want to build this like y is equal to 50 times 0.02 to the x. I don't want to do that, because that will get us how much is lost, not how much is left. So I need to do the opposite of the 2%, which would be, that's right, ladies and gentlemen, that would be 98%. So the exponential is y is equal to 50 times 0.98 to the x. Now, that will tell you this is a good exponential equation, because I'll tell you, okay, that's how much I need to find for this and how much I need to find of that. Definitely good if you want to find y. But let's say you want to find the x. Well, what's the logarithmic? That is going to be log of y divided by 50 of base 0.98 is equal to x. All right. So that, I think, is pretty good on finding my two equations. One for an exponential, one for the logarithmic. They are both roughly saying that they are saying the same thing. They're just going in opposite directions because they're inverse functions. We want to find the time it takes to for only half of the initial amount to remain. So, point of this question is to find the time. Now, out of these two variables we have, y and x, the question is, which one's time? Which one are we trying to find? Are we going to be using the one on the left? Or are we going to be using the one on the right? Well, the thing is, it goes back to our independent and dependent variables. You can control how much of a substance there is, right? Like there's either substance or there's not substance. And if you can add substance or take away substance, that means your substance would be dependent. But, ladies and gentlemen, can you control time? Well, you could probably control time on this video just by hitting the pause button, but in all actuality, you can't control time. Time is independent. And we know that x is independent. We're trying to find that variable, so we have to use the logarithm. Or you could say, hey, Mr. K, this episode's about logarithms, so maybe we need to use the log one. That's right, you do need to use the log one. So, find the time it takes for only half the initial amount to remain. Well, Mr. K, it doesn't tell us how much it has. Well, it actually has. If we started with 50, what's half of 50? 25. So all I need to do is log of 25 divided by 50 with a base of 98. And that's equal to x. Well, what's 25 divided by 50? 0.5. So this is log of 0.5 with a base 0.98. Now, we just use that equation. Log of 0.5 divided by log of 0.98. Well, what I have written down here is that that's equivalent to about 34.31 years. Let me just double check that really quick. I know that I'm not completely perfect on these. Ran out of room there. All right. Log of 0.5 divided by log of 0.98. Let me use my 0.5. Please excuse us while we experience technical difficulties. Oh. 3010 divided by log 0.98. Yeah, it's 34.1 years. Woohoo! So, it takes this radioactive substance about 34.31 years to go from 50 kilograms to 25 kilograms. That's why nuclear energy is so confusing. But, ladies and gentlemen, for your check for understanding, take your time, pause this video, work it out. What I got for my answer is that the population of a small town is growing at 3.5% per year. If the current population is 12,500, how many years will it take the population to get past 20,000? Well, one thing I will tell you is that your rate isn't 3.5%. Rate's got to be bigger than 1, because that means it's growing. So your rate is going to be 1.035. The time it takes for this to grow is about 13.66 years. Alright, ladies and gentlemen, that's going to be my end of my episode today. I hope you guys have a good weekend. I am not going to do any episodes on the weekend because I don't get paid for the weekends. But anyways, leave a comment. Also, for all my students, you should have hopefully gotten an email or one of the other students told you that yes, in Microsoft Teams, we do have class now. You can find a lot of your materials there. You'll find these videos there. But I will be giving out some assignments. I will be giving out things to be like, hey, this is what you should work on. This is what you should work on. Check your emails. If you don't have an email, check with a friend who does have an email with the school and try to get a hold of this stuff. Ladies and gentlemen, once again, hope you have a good weekend. Signing off.